Good evening. All right, here's a few news stories that I thought were interesting, and probably the better one. We'll skip right to the hardware stuff, which is actually most relevant to this Android class. So this guy decided to analyze Christmas lights. We have these smart devices, and he found some device that only cost £2.38, so that's cheap. He bought them, and they are lights that will blink lights with various patterns, and then he analyzed the protocols. So he had to see the Bluetooth. This one I thought was very interesting. I do not know how to sniff Bluetooth packets, but he does, and I think I should try it. You use a Android device, enable developer mode, and enable Bluetooth HCI Snoop. And this apparently gives you Bluetooth packets. You can examine them in Wireshark, which is very interesting, and something we are going to be playing with in this class, although not deliberately Bluetooth. And so anyway, he was able to examine the packets sent by these lights, and he found turning the lights on and off is just a simple repeating pattern ending in 0 or 1 to turn the lights on or off. But other packets are sort of long and complicated looking, and so all he did was go look at the source code of the Android app, which we're also going to do extensively in this class. Android apps are distributed with their source code. You can just read it. They can't hide any secrets from you. You can just decompile it back into Java, and you can read the Java. And so he read the Java, and right here, it imports AES and uses a key that's just a static key right there in the source code. So he's able to decode the packets, and now again, these turn into just long strings with a 0 to 1 turning things on and off. So he was able to totally reverse engineer the protocol and then hunt for special protocols. He found that there were 10 modes for the light, but it was a 1 byte value. It could go higher, so he changed it to 11 and found a new mode, changed it to 12, and bricked the lights. They're dead. They won't come back on at all. He's destroyed the firmware due to a vulnerability of some sort, which, by the way, is the kind of thing you look for in network security. If there's a packet that will damage the server, that means there's a vulnerability, and you can turn that into a better exploit more carefully. Now, this guy did not know how to restore the firmware, so that was the end of his investigation, but it's good as far as it went. And what's better is to figure out how to restore the original firmware and then analyze why it crashed, and then you can make an exploit out of it. Now this one, I think I have to open in a private window, get past their paywall. All right, so this is interesting. I've talked to people about this quite a lot. You know, cryptocurrencies came out years ago, and people said they're good for crime because you're hiding your information about you, and that's of course not true. And this is the woman that figured it out first in 2013. She figured out how to de-anonymize Bitcoin, and what she did was just make an awful lot of transactions with Bitcoin, turning dollars into Bitcoin, trading it from one wallet to another, running it through exchanges and stuff, and she tracked those purchases on the blockchain and figured out how to follow them, and now there are a lot of companies that do this for law enforcement and other people. And it's so successful that when the Colonial Oil Pipeline got hit with ransomware about 2 years ago, and they had to pay something like $8 million in Bitcoin, the US government was able to track that payment and steal it back off the wire, so that money didn't actually make its way to the criminal, most of it. So you know, criminals that think they're going to use Bitcoin for anonymous transactions are out of date. It is possible, by the way, to perform transactions on the Bitcoin blockchain that cannot be intercepted by law enforcement. But you have to know what you're doing. If you just casually use online services like Coinbase, then you are going through what is effectively a real bank with know your customer rules and with association with the FBI and law enforcement and tax agencies and everything else, and they will catch it and impound your money as it passes through. The original point of the blockchain was to escape government control, and it does do that, but only if you are a sophisticated user. The average users do not succeed in escaping government control the way they use cryptocurrencies. This I thought was very clever. I'm consulting for a company using a lot of Amazon images, and they're having trouble because their Amazon images have vulnerabilities and the developer is too slow to patch them, so they're having trouble achieving compliance with the vulnerability requirements. But this I thought is a good thing. Now Amazon has decided to do this. They're going to charge you 6 times as much for an Amazon image if it's out of date. This is a gentle way to convince you that you really ought to update your images. So I think that's pretty clever. We'll see how that turns out, but that's not a bad idea at all to motivate people to update their images. So this is another one, which I thought was very interesting, very much in the spirit of these classes. So what this guy did was he found Toyota Motors which is a India subdomain, an insurance broker. And at this place, you can sign up for insurance. And when you do, you fill in your customer name and account number and other stuff in some form and send it up to the server, and it does some calculation to decide like how much your insurance would cost. So you looked at this, the source code to the website, and you see it send up the data here, and it uses something called a JWT token. So that's going to be your authorization to use the API. That's going to be a token, and you might not be able to get that. But what he did was he just made a request without the JWT token in it. And he said, well, I'll probably just get a 501 error saying, server error, I can't process this request. But what he got was an internal server error followed by dumping the logs from the server, this is a fairly common web vulnerability, overly informative error messages. A lot of services, if we default install, when there's an error, they will dump out the error, the details. Here's the code that caused the error. I found this on the Republican National Committee website about 8 years ago. And so it dumps the log, and the log includes the password for the email account this was going to, because it shows the raw, look, this is raw email protocol. ELO is hello, start TLS. These are the email commands. This is SMTP language. And the SMTP passes authentication up by just base64ing it. So this is probably the base64 username. The thing shaded out is the base64 encoded password. So now he was able to log into their email server. And in the email server, which is a do not reply address, he found it was saving all their sent messages to everybody, including other people's names and passwords and all kinds of secrets. And so it's pretty amazing. And this kind of thing that happens. You find holes, and they don't have to be super sophisticated very often to get in. This is another interesting idea. You know, airplanes have a black box. They have a recorder that records the sounds in the cockpit and the motions the airplane controls. So if it crashes, they can figure out what's going on. And they're trying to put this in hospitals. I've been waiting for years for like Yelp for doctors. I mean, a lot of people complain, this guy, doctor's an idiot, they messed me up. You ought to be able to just read online reviews of doctors. As far as I know, nobody can do that in America because the doctors will sue. But this is getting close to it. What they're doing is they're using AI to anonymize the face of the doctor and replace the people with cartoons, so they find out what was done in surgery. And they're also deleting the records after 30 days to try to avoid terrifying the doctors, but they would like to have a record of what procedures were done and what errors are made so they can learn not to quit making those errors. This is a huge problem. You know, malpractice is such a huge problem for doctors that they're really not happy with any form of supervision or responsibility or consequences for bad actions. And I must say, even teachers have the same thing. There used to be a site called teacherreview.com. It was written in a web design class by students at this college. They put it up, they started reviewing teachers, and of course, there were two teachers that were utterly hated. There was an English teacher and a literature teacher at this college, and there were just hundreds of screaming, blasphemous, obscene reviews of how terrible these guys were. Yeah?
They still have it. It's Rate My Professor.
Yeah, it moved, Rate My Professor bought it, and they removed all the negative reviews, and they gave teachers the right to complain about reviews, and they continued to run it. And I highly recommend using Rate My Professor, by the way. The point is, back when there was teacher review, it was going up and down with lawsuits, and I made one on my website just so people could comment about my classes, because I thought this was a good idea, and there was a flood of complaints everywhere on all the social media. As far as I can tell, 99% of teachers think this is the end of the world, this should be illegal, you should never do it, it's horrible. The very thought that students would tell other students what they think of my class would ruin my life. And you know, you're fooling yourself. Students tell each other what's going on. Anyway, but the doctors, it's even more so. So anyway, it's interesting. There will be some kind of black box in some of these surgeries. They're trying to record what mistakes doctors make. And I think that might be enough. Let me check the online thing for comments. This is 128. Yep, you're in the right place. And did, all right. And I just want to mention this one. CPUs have pretty strong security boundaries now. There have been some vulnerabilities, some famous ones called Spectre and Meltdown and others, in CPUs where under certain circumstances you can see across a security boundary. One user can see data they were not supposed to be able to see. But CPUs have narrowed that down quite a lot. But GPUs, the graphics processing units, are designed for performance, for playing games and stuff, and security has not yet been a major consideration. So these guys found a whole series of flaws in the GPU code, and they made a fun proof of concept here, where over here is someone talking to a chatbot, and here is another attacker who is not authorized to see that data. And as you can see, after about 10 seconds, they can see a lot of that data. So they're able to leak past the security barrier because the GPUs don't have the protections that CPUs have. So this will have to be addressed probably with hardware updates, possibly some kind of firmware updates. But anyway, it's an interesting thing to know. When you forbid something on computers, it's entirely possible that it isn't really forbidden. Anyway, let me stop this